Working remotely completely changed my life. Now I have time, energy, and freedom to enjoy the things I love. That's why I created a free training showing the exact steps I use to attract remote opportunities. Check the link below and get free access right now. Today is the day when you stop writing scripts and start writing software. Basically, what I'm going to teach you today is going to separate you from the programmers that only know how to write scripts. Because today is the day when I'm going to teach you how to write reusable code. And if you don't know what is a reusable code, it's basically a way of writing code that allows you to grow your application, to grow your software in an organized way, and it allows you, as a consequence, to create more robust applications without losing control of your code. All right? So basically, this represents the scripts that you are used to write. They are basically one line of code below the other, and they basically perform some operation. You put some conditions, some loops, and that's okay. This brought you to this level that you are right now. But to become a professional developer, you must be able to organize things as they grow. So the first thing you are going to learn is how to turn these lines of code, these little scripts that you know how to write, into functions. Okay, so I'm going to put these lines of code into this box, and you're going to call this function, right? Basically, a function is a group of lines of code that do something, and you encapsulate these lines of code and give them a name. This allows you to call that lines of code all the way across your software. All right, so you write once and you call every time you need. Once you learn how to write a function, you are going to be able to write many functions. So you are going to write many functions, and you are going to learn how to turn this group of functions into something that we call module. Alright, so we are going to aggregate all of these functions into something that we call module. And at this point, you're going to be able to write many modules, right? So when you write many modules, you are going to be able to put all of these modules inside another bigger box that we call package. So package, or you can call it library. There is a small difference between packages and libraries, but you're going to understand this soon, all right? But for now, this is what you need to know. Take a look. You are here. Today, you know how to do this. In this moment, you know how to write this, the lines of code, as a script. And this is basically what most programmers know how to do, right? By the end of this lesson, you are going to reach another level of writing code, because you are going to learn how to turn these lines of code, these little scripts, into functions. Then you will become able to write many functions, and this is going to require that you also organize your functions. and you are going to group them into modules. But as a consequence, you are going to start writing many modules. So you are going to organize them into packages and libraries, right? So can you see the new level of programming that you're going to achieve by the end of this lesson? But we are also going to see more, right? Because when you reach this level of writing software, you are going to start reusing your code, right? So for example, this module right here have these functions, but this function right here, one of the lines of this function can be basically the calling of the calling of this function, you know? So this is why I call this lesson code reuse, because when you have this level of software, you are probably going to see situations where inside of one function of one module, you are going to notice that one of the lines that you thought that you needed to write, you have already written in a function that is part of another module. So instead of rewriting and duplicating your code, you can just call that function. You can just, in this line of code here, you can just use the function that you wrote here, you know? You're going to understand all of this because you're going to write all of this by the end of this lesson. And to finish, I'm going to show you how to manage the dependencies, right? Because in this case, if you are trying to run this module and you are using this function, but this line of code depends on this module because it uses this function, you have something that we call dependencies, right? And these dependencies here must be managed, and there are some professional techniques that I'm going to show you to manage these dependencies. And trust me, by the end of this lesson, you are going to reach a new level of writing software. Most developers only know how to write scripts. That is basically this part of my metaphor, right? This part. By the end of this lesson, you are going to be able to write all of this, okay? All of this. So without further ado, let's dive in. Alright, just created a functions.py file here for us to demonstrate how functions work, alright? So the functions are basically the smallest unit of reusable code that you can write. So instead of writing line by line and then running your file, characterizing a script, now you're going to make a transition to your code look like a software, not a script. So let's use a situation where we need to calculate the total price of a product. Basically, the product has a price, and this product, based on the value, must have an addition of a tax. We would create a variable called product name, and this product name would be iPhone. Product price 20,000 BRL, that is my currency here in Brazil. And the tax that we can put as known And we can put some conditions here to assign the tax value. So if product price is greater than 10,000, tax is going to be 5%, right? 0.05 is 5%. Else, tax is going to be 2%, right? Pretty simple, just for demonstration purposes. So we have the tax, and this tax right here can have a value based on the price of the product. So now we can calculate the final price, right? So final price, total price is better, is going to be the product price plus, between parentheses, product price times tax, right? Let's change the name of the variables because, to be honest, we are talking about the total price of a product, so we don't need to put the name of the variable in the name of the variable the word product, right? Our context already tells us that this is about the total price of the product, okay? And we can make this clear in the messages that we're gonna print. All right, so this code right here basically calculates, and we can print total price. So this script basically calculates the total price of the product and prints for us to see. Let's run. And there you go, we have the final price, the total price. So here comes the problem. Basically, this script, if the store that is selling this iPhone needed to calculate the total price of all of its products, and they are many ones, they basically have 1,000 products with different prices. This script right here is not a good solution for this scenario, right? Because someone will need to change the name and the price and run every time as a calculator. But this is not a calculator, this is a software, or at least we are trying to make this a software. So we need to evolve this script level code to software level code. The first thing we do is creating the functions that are the smallest unit of reusable code that we can write. So functions basically work like this. Instead of writing your code in the Python file directly, first you declare a name to this function, and then you write the logic inside of the function. Like this: def calculate total price, open close parentheses, and colon. That's how you declare a function. Pretty simple. So you use the keyword def, you give it a name, and this name must represent the logic that is inside of it is doing, right? You open and close parentheses and put a colon. Everything you do inside of this function is going to be executed when you call the function, right? So let's put all of this code right here inside of the function, pressing tab, right? So now we have the function calculate total price, and all of this is going to be executed when this function is called. And to prove this, I'm going to run the file now, and you're going to see that nothing happens. Nothing happens because we just created the function, and even if we put all of our code inside of this function, if we don't call it, it's not gonna run. Alright, in order to run, we need to call the function, we need to invoke the function. To do that, we simply put the name of the function like this. Visual Code already suggests the name because it recognizes that in this file we have a function that is called calculate total, and it recognizes the similarity of the name, right? So we can just click and open and close parentheses, okay? Not just the name with opening and closing parentheses. Now if I run, now it prints the final value. So again, if I only declare and create the function, if I run the file, nothing happens. But if I call the function with the name, like this, and run my file, it is going to run because the function is being called, is being invoked. But we still didn't achieve the best form of our reusable code, because you can see that basically we are putting the logic inside of a function, the same script logic inside of a function. We only took one step of improvement because we created the function, we encapsulated the logic inside of the function, and we invoked the function. We have run this logic using a reusable code, and this is one step of improvement, because now all the way across my software, my application, if I call this function, this block of code is going to be executed. I don't need to rewrite it all across my application, okay? But still we don't have the best form because we are hard coding some data here. We call the function, and inside of the function we are not exactly calculating the total price. We are still calculating the total price of the iPhone that costs us 20 kBRL. This function only serves to calculate the iPhone tax, and this specific iPhone here that costs this value. Do you agree? But how can we improve this? How can we make this function more reusable, you know, in a way that when we call the function, we tell the function the product and the price that we need the function to calculate the total price. In order to do this, we use parameters. So let's get rid of all of this, and you see that our variable price here is already marked as red, like something is wrong, right? Because how can this decision structure use the price if we don't have the price anymore? How can this formula that calculates the percentage that must be added into the price to generate the total price, how can it calculate if it doesn't have the price anymore? So here is when the parameters comes in. The parameters are basically variables that our functions can expect. In this case, for example, in order to calculate total price, to work properly, it needs the price, right? So between the parentheses of the declaration of the function, we can add a parameter that is basically a variable, right? So you can call it price. What does this function need in order to the logic that it's inside work? What is the external data that those who call the function must pass, must inform? The price, right? I'm telling basically this function, calculate the total price, but based on which price? This is what the function expects. So we can put here inside of the parentheses, and this is basically is going to work as a variable, right? A local variable and a temporary variable to this function. So if I pass the price as a parameter, all of this code is going to be executed using the data that those who call this function are going to pass as a parameter. In this case, so let's see what happens now. Same thing, now it works. If I try to run this function without passing the parameter, we have a type error, missing one required positional argument, that is the price, right? So you already know how the exceptions work. You know that if someone calls this function without passing the price, it is going to break the execution, returning the type error. You can handle the exception inside of the function, and don't allow anyone to call this function without passing the price, right? So let me put the price again. Let's see what happens. It has added 600 BRL into the price. But now let's change this value. Let's pass a value that is less than 10,000. Let's pass 9,000 and see what happens. We can see that the increment is different because of this dynamic here. So can you see how beautiful our code is becoming? Now, all across our application, everyone that needs to calculate a total price using these business rules, of course, can just call this function passing the price. But there's still one missing thing that you need to know. When we write functions, our goal is to make this block of code reusable for any part of our application, any part of our software. And we need to think what those who are calling want in return. You might be probably thinking, of course, they are waiting for the calculate total price function returns the total price, right? Yes, but we are not returning. We are not returning the total price here. We are printing the total price. You can see it like this. If I print this, basically I'm telling Python, print the return of this function. Print what this function is going to return for me, right? So let's see what's going to be printed. None. You can see that the value is here because we have this print inside of the function. So it executes this code, prints in the console, but the calling of the function is printing none. Why is that? Because we are printing, we are not returning. And we are used to print because we need to see what we are doing during our development sessions, right? So we got used to print in the console for us to see. But this is not a return. Even if you are seeing with your eyes in the console, is not a return. A return must be like this: return total price, using this keyword right here. So most functions have the return as the final line, right? Because you do all you need to do, and then you return the result for those who called the function. So in this case, I'm calling the function right here, and now you're gonna see that it's not known anymore, because this line of code right here is basically telling Python, print the result of this function, print the return of this function, print the data that this function returned after finishing its execution. You know, if I get rid of this print that is inside of the calculate total price function, you're gonna see that it only appears once. And even better, if I get rid of all of the prints, you are not gonna see nothing printed in my console. But that doesn't mean that it didn't return. It returned, but we didn't do nothing with this return. So if I create a variable here like total price receives, the data that the function calculate total price is going to return, and then I print this data right here. Now you're gonna see that it appears again. You know, you can debug all of this and see the execution line by line for you to understand how the functions work, right? But this is basically how they work. So you define a name for the function using the def keyword. If this function expects some data to be passed in order to use inside of its logic, you must add as a parameter here. You perform your logic normally as you did in the script mode, but now inside of the function and only with what really needs to be inside of this function. And in the end, you return the final data. But remember, if you only do this, you are going to create a function but never call. You are going to get your function ready to be called but still not called. That's why in the same file here we called in many different ways in order to see how it worked. So we called only the function and we didn't see nothing. We printed the calling of the function and we saw the final data printed in our console, and we called assigning the calling to a variable, because the data that's being returned goes to the variable and then we have printed the variable. Just for the record, you don't need to do this, right? I just did the calling in the same file for you to see the function calling working. But we could write 100 functions in this file and never call them here, and only organizing the blocks of code inside of functions to be called by other file That is something that you're gonna see in the next topic. Now let's move on to the modules. Because you already know how to write a function, your next natural step is writing many functions. And when you write many functions in one Python file, this is basically called a module, right? There are some tricks to write your modules the right way, and there are some useful techniques that you can use to reuse your code throughout your application, and I'm gonna show you right now. All right, so let's create a new file called purchase.py. This is gonna be our module that is going to take care of the full process of a purchase. All right, and just for the record, what I'm going to show you right now is not the best way to write a module. Right, I'm only going to write this way for you to see how it works, and in the next steps we are going to improve this. All right, but let's try to think how an user that is logged in a platform that sells products online, what does the user do? What is the process that this user is going to run to make a purchase? Let me close this. So first, the user is going to see the products that are available. Second, the user is going to add products to the cart. After choosing the products that the user wants to buy, it is going to add the product to the cart. When the user finishes adding the products to the cart, the user is going to make an order. Right? The user is going to create the order, and then the user is going to pay for the order. And to finish this process, the user is going to receive notifications about the status. So this is a basic process of a purchase online, and we can write functions in this purchase module to represent all of this. So here in this first step, the user needs to see the products that are available. We could create a function called list products, and then implement this logic right here. See the products that are available. Products receive known, return products. Just for demonstration purposes, alright? We don't need to implement the logic for now. So here we would implement the function add to cart. As a parameter, we could pass a list of products. Cart receives products, and then return cart. So add to cart. What else? Then the user can make this order. So def make order. We could pass the parameter cart ID to identify which cart is going to become the order. Right. So we'll make an order and cart ID. Order receives cart ID and all of the process. Remember that we are just simulating some little logic here inside of the functions for you to see how the process of creating multiple functions inside of the same file works, right? If you were to implement these functions in real life, you need to really write the logic that does the thing that the name of the function says that it does, right? So anyway, return order, and the user would pay. Could pass the order as a parameter, the order ID as a parameter, and if we need to pass multiple parameters, we can just put a comma here and put the name of the other parameter. We could pass many parameters if we wanted. For example, in the pay function, we could pass the order ID and the payment method. So here we would basically pay for the order, payment status, receives, processed, return, payment status. Great. In this case, I thought about the receive notifications because the user is going to receive, right? But in our system is going to send the notification. So send notifications about the status. This could be a function called send notification. We could pass as a parameter like the user email to send the notification and the status. So sending status receives sent, and we return sending status. Alright, so basically this is the purchase module, because we have a Python file, we have multiple functions that are aggregated and they are part of a context. All of these functions are necessary to make the purchase. So this is basically how you write your own module. But this example is the common example of a first module that a beginner programmer writes, because although all of these functions are part of the same context, they are not. Because they are part of the context purchase, but purchase is a context that is too large for you to write the functions in just one module. If you see here, each function belongs to one isolated context. For example, list products. Alright, it belongs to the purchase, but you have a small context that this function fits better. That is the context product. Same thing to the cart, same thing to the order, to the payment, and to the notifications. Each function that we have written belongs to one unique, smaller context. And how can you see this? How can you notice if the functions that you have written should be in this context or in a smaller context? The technique that I apply is basically I look at that function and I question, is this function part of a CRUD operation? If you don't know this term, CRUD basically stands for create, read, update, and delete. If your function fits one of these four operations, that means that probably in the future you're gonna need to write the other ones. Let's see an example here. List products. Basically, this is a read of a CRUD operation. We are reading the data that represents our product. And if we are reading, probably in the future we are going to need to write functions that creates new products, that updates the existing product, and that deletes the existing products. So this function right here already indicates that in the future we're probably gonna have 4 functions about products. Same thing to the cart. Here we are adding items to the cart. If we can add a product to the cart, we're probably gonna need a function that removes the product from the cart. We are probably gonna need a function that updates the cart. And we are probably gonna need a function that deletes the cart. So now let's expand this and let's create a folder called purchase. Instead of creating a file called purchase, we are going to create a folder called purchase. And inside of this folder, we are going to create the modules that we already know that we are gonna need in the future. Alright, so products, it's the first one, products.py. Cart is another one, cart.py. Order is another one, so order.py. Payment is another one, so payment.py. And notifications is another one, also notifications.py. And in this case, our file purchase.py is going to become obsolete. I don't know how to say it. Leave in the comments, please. Help me with my English. But let's cut this and put in the module products. Let's do the same thing with the add to cart and put in the cart module. Yeah, let's do the same thing with the order. Let's do the same thing with the payment. And let's finish doing the same thing with the notification. Alright, so now instead of having one module with many functions that belong to different contexts, now I have one file per context that represents only that context. And now I'm free to write many other functions that belong to each context inside of each module without growing my code in a messy way, right? Because in our purchase module, if I needed to write each function from each context in the same file, I would have dozens of functions mixed up, and the maintenance would be way harder than now that we have spread it into the right modules, you know. So in this module notifications.py, for example, We are going to call this function to send an email to notify our user about the status of a specific order. But in the future, I could want to send this notification not via email, but also via WhatsApp. I could want to send via SMS. Do you agree with me? Notification via WhatsApp. Can you see that I already have 3 functions? In a matter of less than a minute, I've already increased the notification context with 2 more functions. And this is gonna happen with all of the modules that I've just created. As the business rules start to appear, we're gonna need to write new functions. So now you can see that even creating new functions here, I'm still organized, because all of this is about notifications, and all of this is aggregated into the notifications module. In this case, the name send notification doesn't make any sense anymore, because the other ones have the name of the channel. So here we're gonna send email. So that's how you create your own modules in Python. And in the next topic, I'm gonna show you how to call and invoke the functions across your modules to start integrating them. And also, I'm gonna show you the modules that Python already provides for us to use. If you still didn't notice, Python already have many modules that comes with Python that have many functions, and we can just use these functions. So stick with me and let's go to the next topic. Another thing you should know about the modules in Python is how to call the functions across the modules. Because if you have a reusable block of code, that is the functions that you already know how to write, and if you already know how to organize them into modules, the next natural step is calling them across the modules. Alright, so let's use this notifications.py module as an example for us to call a function in the same module before we start calling functions across module. So let's use an example here. We have in this notifications.py module 3 functions. One sends an email, another sends WhatsApp, and another sends SMS. Let me correct this. Let's pretend that we have some email templates that our function should choose based on some rules. So here we are expecting as a parameter the payment status. So let me improve this, payment status. And let's pretend that based on the payment status, we need to choose the template. So we will do something like if payment status, let me close this, equals processed Then we should choose processed template. If payment status equals error, choose error template. Else, choose generic template. So we can see here that we have 3 templates. We are pretending that we have 3 templates, right? And based on the payment status, we are going to choose the template. Let's add the template, the fake template, just a variable, in order not to be empty. All right. So can you see that now we have multiple lines of code that not exactly has something to do with the sending of the email. This specific block of code that chooses the template should be a separated function, because this block of code does something that is not exactly sending the email inside of the function that sends the email. So of course, choosing the template is part of the process, but should not be inside of the function send email. So let me cut this and create another function called choose template. And I can put the logic that chooses the template here. And this is a situation where we need to call another function of our module from the same module inside of other function. You can call this nested function, the same way you have learned how to write a nested loop, that is a loop inside of other loop. You can do the same thing with the functions. You can call a function inside of other function. So the function send email can call the function choose template, of course passing the parameter payment status, because this is what the function needs in order to choose the right template. So here we need to expect the payment status, and in this case we can assign the result of this function, the data that is going to be returned by this function inside of a variable, in this case template. Choose template, passing payment status, is going to call this function right here. It is going to choose the template based on the payment status, and it is going to return template. Alright, so chooses and returns the template for those who are calling, in this case send email. When it chooses the template, the return is going to be assigned to this variable right here, and now the logic that sends the email can use the template that have been chosen by the function choose template. So this is how you call a function from the same module that you are writing the parent function, right? So this is a nested function. You have the send email. Inside of send email, you call choose template that belongs to the same module here. You could implement this block of code inside of send email. Yes, you could, but you should not. Because The responsibility of the function send email is just send email. If it needs to choose the template, the logic that chooses the template should be separated and just called as another reusable block of code. Okay? Exactly like this. And from now on, I need you to take care with the nested functions, because now you know how to use them. You are going to start having some ideas to put many functions one inside of the other in order to one function to call the other one, and so on. And I just need you to be careful, because you can create a code that is too dependent. You might end up writing a module that has multiple layers of dependencies, and this is not good as well. So the same way that writing functions that has dozens of lines of code is not good, writing functions that call multiple other functions, and these multiple other functions also call multiple other functions, is not that good as well. Alright, so you should be careful in order to not create this type of spaghetti code. If you write deeply nested functions, you are going to end up creating a tight coupled code, and you are going to end up creating the same problem that the modules and the functions should solve. Okay, so just be careful. And now let's start calling our functions across our modules. So we have now the send email function that calls the choose template function and uses this template to send the email. Uses the template to send email. Remember, we are just putting comments here instead of writing the logic, because if we implement every function in this lesson is never going to end. The next topic, we're probably going to implement some of this logic, because we're going to understand how built-in modules work. But for now, let's just stick with the comments that represent the logic that's supposed to be here. Okay? So now we have the function send email that calls the function choose template. And I want to ask you, which function should call send email? I guess the function pay, right? Because after the payment, we notify our client about the payment status. So here we perform the payment, and right after that we notify. How can we notify? Do we have something in our system, in our application, that allows us to send this notification? Yes, we have. We are in the payment module now, but we have the notifications module that allows us to send notifications. And we know that we have the function send email specifically. That is the function that sends the email with the status, right? So we can just call the function, right? Let's try to do and see if it works. So we're gonna type here the name of the function, that is send email. Let me see the name of the function, send email. And this is not gonna work. Why this is not gonna work? Because the function send email does not belong to the payment module. If you place your cursor in the function, you're gonna see that PyLint tells us that send email is not defined, and it's not defined because it does not belong to this module. We didn't declare here. We declared this function here in the notifications module. So we can just import the modules that we want to use their functions. To do this, it's pretty simple. You can just, in the top of your file, you can type import name of the module. So in this case, notifications. You don't need to type .py because it's a module and Python already recognizes that you are talking about this file right here. Okay, so import notifications, and now Python recognizes the function is still marked as red because we need to put in front of the function the name of the module that it belongs. So in this case, notifications dot send email. All right, and now our function is going to be recognized, but is still marked as red because this function is expecting a parameter. So let's see which parameter this function is expecting. We can just press Ctrl in your keyboard and click in the name of the function. That is going to open the module and the exact function. Okay. We need to pass user email and payment status. So back to our payment module, let's pass the user email here, and let's pass hard-coded. In this function, we don't have access to the user email, which we will need to implement this, passing as a parameter in the function pay, or calling another function that gets the email of the user based on the order ID. So let's pass as a parameter the first, that is the email. So example at gmail.com, and let's pass the other parameter, that is the payment status, and this payment status we have as a variable, so we can pass here. All right, and now it's not marked as red anymore because we have imported the module that the function that we need to use belongs to, and we have specified like the name of the module dot name of the function. All right, this is the first way of doing this, but there are some modules that they have like giant names, you know. So notifications is a long name, but there are modules that have like longer names than notifications. So there's a technique that you can use. You can give the module an alias, basically a short name. So when you import it, you can type S and type the alias that you want to give to the module. I'm gonna put like the initial letters, like an O, and here instead of writing notifications dot name of the function, I can just type no dot name of the function. So it's a prettier way to type the name of the module. Okay, but there's a even better way, because if we go to the notifications module, we are gonna see that this module has like 1, 2, 3, 4 functions. In my payment module, I just want to use one function. So if I just need to use one function, why do I need to import the whole module? And the answer is you don't need to import the whole module. You can just import the function that you need. All right, and in this case you write a little bit different. Instead of writing import name of the module, you type from name of the module, in this case notifications, import name of the function, in this case send email. Okay, and now you don't need to put neither the name of the module and the alias in front of the name of the function. You can just type the name of the function as if this function was declared in this module, right? Because you just imported the specific function from this module in the top of your file. So basically now this function that belongs to this module now is part of this module, okay? And you can just type the name without putting the name of the module or the alias, right? So these are the basic ways that you can call function across modules, but you're probably thinking that even knowing how to organize your functions into modules, how to call functions in this nested way, and how to import functions from another modules in one specific module to use these functions that doesn't belong to the module that you are writing. Even knowing all of this, you are probably noticing that we have a lack of power, because all of these techniques only allow us to organize your code and to write cleaner code, reusable code. But where's the power of the Python platform, the Python language? How can we, instead of only writing the comments that represent the payment, how can we literally write a code that makes a payment? Instead of only writing the comments that represent the choosing of the template, how can we write a code that literally chooses a template? How can we write a code that literally sends the email? That's what we are going to start diving in the next topic. Let's end our lesson on a high note. You already know how to write functions, how to write modules, how to call the functions across your modules. And now it's time for you to know how to use the Python built-in modules. So the first thing I'm gonna do here in our folder purchase, where we have created our modules, our first modules, I'm going to create a new file called main.py, because we're going to start to use many functions, and these functions are going to be distributed in our own modules and also in Python built-in modules. And in order to organize things, we're going to use the main.py file that is going to be our orchestrator, you know, where we are going to test things and demonstrate things and so on. So the first thing I need to demonstrate for you is this function right here that is called help. If you type help and pass modules as a parameter, and especially if you print this, you're gonna see that Python main.py, you're gonna see that Python is going to list for you all of the modules that are available, all of the modules that comes with Python, all the built-in modules, and you can see that they are many. These 4 columns are the Python built-in modules. So in the second column right here, for example, we have some modules like the date time. This is a pretty important module that you're gonna use every single day if you become a professional developer. In the third column here, we have the HTTP module. That is also another pretty important module. The JSON module, the login module. We have many modules here. Pathlib, pretty important. Anyway, All of these modules are important in some way, and you don't need to know all of them, but you need to know that they exist. So the same way your modules are groups of functions that you can reuse, Python already provides you modules with functions that you can just import and use. And we are going to implement some of them. We are going to use some of them to finish this lesson. I'm going to implement in our own modules. I'm going to reuse functions that belongs to the Python built-in modules. But first I need to make some disclaimers for you to understand how this is going to work. First, you're gonna notice that some of the built-in modules don't look like a module when you call their functions. This is gonna happen because some of these modules have sub-modules. That is something that you don't know how it works for now. Some of these modules have classes, have constructor methods, and to understand how they work, you need at least a basic knowledge about object-oriented programming. That is also something that I'm going to teach you in the future. So the basic pattern of importing a module and typing name of the module dot name of the function, you are probably going to notice that this pattern doesn't appear in every module that I'm going to use. But one thing you are going to notice, that the main goal in every single module that I'm going to use is the same. Reuse the function that the module provides, and that is waiting for me just to import and use one way or another. Okay, this is the first disclaimer. And the second disclaimer is I'm not going to explain line by line of what I am doing when I start to implement the real logic of our functions, especially when I use built-in Python modules. Because if I explain line by line, this lesson is never going to end. So you can just pay attention, understand what I'm doing, and if you want to, you can study the built-in module that I'm using inside of our functions to improve your understanding, alright? But don't worry, you don't need to know every function from every built-in module. You just need to know that they exist and that they solve a problem. And when the time that the opportunity of using that module comes, you are going to remember that the module exists. Let's start with our order.py, because we have here the make order. And here I'm going to change to create order. This name, I guess it's better. Let's get rid of this. And the first built-in module that you are going to see today is the SQLite tree. So import SQLite tree. Basically, this is a Python built-in module that allows us to create little local databases inside of our application. Okay, it's not a production use database, it's not a robust database, it's just a file that is going to be created inside of our project for us to have a place to store data temporarily. So our function create order is going to expect the total amount, and this function create order is going to insert in our database the order composed by the order ID, the total amount, and the status of that order. So first thing is connecting with the database or creating it if it doesn't exist. In order to do that, we type con receives SQLite tree dot connect, and we pass as a parameter the name of the database. In this case, it is going to be purchase.db. After that, we can create the cursor, that is basically the object that allows us to interact with the database. So cursor receives con.cursor, And you can see that we have the same pattern here, name of the module dot name of the function parameter creates the connection, or creates the database if it doesn't exist, and then creates the connection. To create the cursor, same thing, this return, that is the connection, dot name of the function, in this case cursor, to create the cursor. Now we can perform SQL queries using this cursor. So cursor dot execute, same pattern. So all of these functions belong to the SQLite 3 module, and here the parameter is gonna be the query that we want to perform. And if you don't know SQL, don't worry, I'm going to write some SQL commands, and after the Python course you can take a SQL course. This is not going to be a problem at all. So let me create my query that creates my table. So create table orders. In fact, I want to create this table if not exists. If not exists, the columns are going to be ID, that is going to be a text, total, that is going to be an int, and status, that is going to be a text also. Okay, so basically with just 3 lines of code, I am creating a local database, a cursor that allows me to interact with this database, and a table with 3 columns. So now let's aggregate all of the data that I need to create this order. So these data are ID, total, and status. Basically, the total amount I'm going to receive as a parameter, so I don't need to declare right here. I can get rid of this. The status is going to be a default status for the moment that this order is being created. So created, this is basically the default status that I need to pass when I create the order. The ID must be a data that is unique. I'm gonna create many orders, multiple orders, and each one must be an unique order. How do I identify an order in a way that is unique? Well, there are many ways of doing it, but now I'm going to use one technique that uses the timestamp as data to generate an unique ID. In this case, I'm going to use another built-in Python module that is called datetime. This module right here allows us to generate dates and times in so many ways that you can study later, because now I'm going to just call the function now. That is the function that returns this time mark. So date time dot now, and in this case this is one of that situations that my disclaimer made clear that is a little bit different than the pattern that you know, because datetime has a submodule. So instead of calling the function like this, only putting the name of the module and the name of the function, I need to put like this, datetime dot now, because it has a freaking submodule. But you can see that the final goal is calling the function now that already exists and already do something. Let's see what is this something. I'm gonna copy this. I'm going to my orchestrator main.py. I'm going going to import date time. I'm going to call this function and I'm going to print, right? Let me open my terminal and let's run the main.py file. This is basically the data that has been generated by this function now, okay? Year, month, day, hour, minute, second, and millisecond. This is a unique data because if I run again the same file with the same function, the data is different, right? You can see here 3 4 4 you can see that now is 3 4 30 okay. And even if I call multiple times in the fastest way that is possible, the millisecond is going to be different, you know. The second is the same, but the millisecond is different. One important thing here is I need to get rid of this hyphen, this space, this colon, this point, you know, so we can do something here that we call method chaining. That is basically performing another function over the result of the previous function. So this returns this, but if I put dot other function here, this other function is going to run over the result of this, okay? And basically the function that I'm going to run over this result is a function that formats this data, deleting all of the unnecessary things for me. That is basically the hyphen, the space, the colon, and the point, the dot. Anyway, this function is strf time, and the parameter is a little bit complex, but don't worry, just pay attention and you're going to understand. And most important, don't be scared, all right? You don't need to know by the top of your head, but let's go. I guess that's how you pass the parameter. I told you, don't be scared, because this is basically the formatting mask that this function wants as a parameter to apply over this result. If you ignore the percentage signs, you're gonna see that basically we have in Y, M, D, H, M, S. That means year, month, day, hour. Let me check if this works. No. MS maybe. This is not millisecond. Anyway, let me get rid of the millisecond here. Let's put just second. Now we have a unique data, and now I'm going to put this into my order module to generate a data that is unique, to use it as an ID. Remember, there are many better ways of generating a unique data to use as an ID, but for now, based on the knowledge that you have until now, let's use this method. Alright, so now we have the ID, we have the status, and we are gonna have the total amount when we call this function and pass the total amount of the order. Okay, to finish this implementation, we need to insert our order into our table orders. So let's call this function again, but now performing another query that is going to be insert into orders value. These question marks are basically the variables that we are going to replace with this tuple that is going to contain these parameters. So the ID, that is this variable, the total amount, that is this variable, and finally the status, that is this variable. That's it. And as a good database practice, we should commit and close. And to finish, let's return the ID. Alright, if we run this function right now, it's probably gonna work, but we are not going to be able to see the order in our database because we only have the function that creates the order. We don't have a function that lists the order that we have previously created. So let's create the function get orders. Def get orders. This function is also going to connect with our database and create the cursor, and is also going to execute a query, but in this case this query is going to be select all from orders. This is a query to retrieve all the records that we have in our table. And we are also going to commit this and close. So now our module order.py has a function that creates the order and gets the orders, all of them. We don't have a function that you pass the ID of that order and it gets all the data of the specific order. You can implement this later. Alright, so in our main.py, our orchestrator, let's import our order module and call the function create order. So order dot create order. Let's create an order that the total amount is going to be 500. Open the terminal again, python main.py, and we have an error here. What is it? Syntax error. Let me see. Let's see here, line 13. Line 13. Insert into orders. Oh, it's values, not value. Alright, let's run it again. Attribute error. Cursor has no attribute comment. Of course, it's not the cursor that we comment, it's the connection. Just a basic error here. Let's change this, con.commit, not cursor.commit. Alright, now it's gonna work, and it didn't break, it didn't return nothing, but of course we didn't print anything, so it supposedly worked. To be sure that it did work, let's call the function get orders, and our function get orders didn't return nothing. Let's see, con SQL purchase DB. First, let's see if our database was created. It was. You can see here that at least the part that creates the database worked because it is here. Oh, I forgot to implement the part that prints the result of this query, right? It is performing, it is getting, but I'm not printing, so of course I'm not gonna see nothing. So let me implement a loop here for row in cursor dot fetch all. That is the function that gets line by line print row. And to be honest, we don't need to comment in this case because we are getting data, so we can just close. Now it's gonna work. So python main.py, and there you go. We have here our record directly retrieved from our local database with the ID that was generated, the value that we passed, and the status that we hard-coded. Can you see how powerful you are going to become when you understand how to use the built-in modules? Look at this. We used a built-in module to create a database, a table inside of this database, and to insert a record into this database, and also to retrieve data from this database. And inside of this process, before we inserted the record, we used another built-in module, that is the datetime, to generate a unique data to use as an ID for this record. With only 2 built-in modules, we were able to improve exponentially the quality of our code and the power of our code. Because previously our order module was just fake, and now, even not using a robust database, a production level database, it uses a database and it performs real SQL queries into this database, both to insert and to retrieve. Once we create the order and we are able to get the order from our database and see the value and see the status, we can pay for this order, right? We can implement now a function that pays this order. So that's why we are moving to our payment module. So the first thing that our function pay must be able to do is really making a payment. How do we usually make a payment in real life? You probably have already heard about PayPal or Stripe. There are many ones. These two are 2 of the most popular ones. They have bank integrations, they have government authorizations to process payments, and they usually provide something that we call APIs. In the future, you are going to understand what is an API. You're going to understand how to consume APIs, how to integrate with APIs, even how to build APIs. But for now, you just need to know that an API is like a module that have functions, but the difference is this module is online and is available for some people that have the credentials to call these functions through the internet. The same way that you import a module and call the function directly in your application, you can use the HTTP protocol to make a request in this online module that have some function. So basically what we will do in our function was making a HTTP request to a payment API. We cannot do this now because, as I told you before, these APIs require credentials, authentication, access key, secret key. Anyway, there are many ways to consume these APIs. You're going to understand in the future. But now we can simulate an HTTP request using a test API, because the HTTP request protocol is pretty much the same for any API that you're going to request through the internet. And the most important thing is you knowing that Python has a built-in module that allows you to make these HTTP requests. And this module is HTTP. But as I told you before, we have some particularities here, and you need to import as http.client. Right? This module has this submodule, and this is the right way to import. So now, using this module, you can use the functions that allow you to integrate with an API. So to do that, you're gonna type conn receives http.client.https connection. Pretty much the same way we did with the database, but now with an HTTP connection. And we're gonna pass as a parameter the public domain of the application that we are trying to establish a connection using the HTTP protocol. It will be paypal.com or stripe.com, but in this case, as we are using a fake API, we are gonna use an URL that is called http://bin.org. You can make your HTTP requests in this URL right here, and it is going to return the HTTP status that an official API would return. Okay, so you can simulate HTTP requests. Let's implement the request. So conn.request post f/post ? Total amount. So this is the HTTP method, this is the function, and this is the parameter. Okay, it's not exactly a function because this is an API, so this is called method or endpoint, but don't worry, you're going to understand this better in the future. And now you can see that the function pay needs to have the total amount that is going to be paid before calling the external API, right? So instead of receiving payment method, let's receive here the total amount. So let's simulate the response of this API. Conn.get response. So the response of the HTTP APIs usually are some codes, and this code right here represents that your request was processed successfully. So we can simulate that if the response dot status is equals to 200, we are going to assume that this represents that our payment has been processed successfully. If our payment has been processed successfully, we can do some things. The first thing is put this payment status here, because it is going to receive processed based on this. So if the response is 200, payment status receives processed. And the other thing that we should do is update the status of our order, right? Because we have created this order and the status is created. But now we have made an HTTP call into a payment provider that processed this payment and returned for us that our payment was processed. So now we need to update this status from created to processed. So here we are also going to import our SQLite 3 built-in module, and we are also going to connect with our database, create the cursor, and execute a query. Alright, but in this case the query is not gonna be the create table operation. In this case, this query is going to be the update, and not only update, but update this specific order, right? Update the specific order that has been paid, right? That's why our pay function expects the order ID as a parameter, because after the payment it is going to update the status of this specific order. But before I implement this query, let's just make things more interesting. Let's create other orders just for us to check if the right order is going to be updated. Okay, so create order. So let's create an order with 100. Let's create another order with 200. If I get orders right now, I'm gonna see that we have 3 orders. Alright, each one with a unique ID and with one value, one total amount, and all of them with the status created. Okay, now I can implement the query that is going to update this status based on the order ID. Update orders set status equals question mark where ID equals question mark, and let's pass the tuple that is going to replace these question marks in the exact order. So the status is going to receive payment status, and the ID is going to receive the order ID, like this. So the status is going to be updated with the payment status that we are going to assign here, where the order ID is equals the order ID that we have passed as a parameter in the moment that we call the function pay. But what if the status is not 200? Let's put an else here. In this case, we need to do the same thing, but with the status failed, not processed. So I could duplicate this code right here and change only the payment status, or I could be smarter and only using the if and the else blocks to map the payment status like this, and outside of the if else I could run the operation in my database. Okay, this way looks cleaner, of course in this case with the status failed. So instead of repeating these lines of code here and here, I could just put these lines of code outside of the if else block, and if the status is 200, payment status receives processed, else failed. And in this case I just update with the status no matter what it is. Alright, but before we finish this function right here, let's return something. So before we run, let's get rid for now of this send email function to get things cleaner, and let's just run the function pay to see what happens. So let's go to the main.py, our orchestrator. Let's import the payment module and let's call the function pay, passing the parameter that it needs. So we have here these 3 orders. Let's pay this order right here. I'm gonna copy the ID, pass here as a parameter, and also pass the total amount. To be honest, this is not as good as it should be because I'm passing the order ID and also passing the total amount of this order. The function that is receiving my order ID could use the order ID to get the total amount. But anyway, just for demonstration purposes, I'm gonna pass the both values. We are going to pay, and then right after we are going to get the orders to see if the status has changed. Okay, let me print this and let's run main.py. I guess we have some problem here. Let's see what's happening. So pay order ID, total amount. All right, total amount, get response, processed, failed. Let's go to reconnect purchase database, cursor. I forgot to commit. so con.commit and con.close. All right. So we didn't do anything because I forgot to commit. And now let's run the main.py again. We can see here that now the exact order is with another status. So we just updated the status of the order based on the response of the API that we called to process our payment. That's how powerful learning how to use the built-in modules can get you. But now let's move on to our last step of implementation here. That is sending the email. So you remember that we have imported the notifications module. In fact, we have imported from the notifications module the send email function. So after all of this, we need to send email. We need to send the email to notify the client about the payment status. And if we press Ctrl and click in the function, we can see that this function has no logic implemented that really sends an email. In fact, we need to choose a template based on the payment status, and then we need to send this template. This is gonna be fun. Let's get rid of this. Let's jump to the choose template function, and based on the payment status, we need to get a specific template. First, let's create these templates here. So inside of our folder purchase, I'm gonna create other folder called templates, and inside of this templates folder, I'm going to create a file called temp processed.txt and other one called temp error.txt. these are going to be our processed and error, and we also have a generic. Alright, so temp generic.txt. So let's put some message here like your payment has been processed successfully. I guess that's how you write it. Let's just put this message here. The error template, let's put oops, your payment has not been processed successfully. I don't know how to spell successfully. Leave in the comments, please. And generic, let's put the generic as like hey, check your bank account to see if the payment was processed successfully. Alright, we have 3 templates now, with one for the error status, another for the generic status, and another for the success status. So each template has a message, and we need to choose a template based on the status. To be honest, this logic already contemplates we pass the payment status as a parameter, and we perform this if else logic here, but we don't access the template to get the content and return for those who are calling, right? So in order to do that, we are also going to use a built-in Python module, and this one is the pathlib. But as I told you before, some modules have a different pattern. So this is from pathlib, import path, exactly like that, with the first letter being uppercase. Okay, when you study object-oriented programming, you're going to understand why this is like this. In our function choose template, let's just get the right template for each situation. So instead of only assigning none as we did before, now we are going to read our template. So to do that, with the pathlib module, we type path, open and close parentheses, we put the path where the file is, in this case is in templates, slash name of the file, to process this file, and copy and paste .txt. Okay, pay attention in the level of the folder in comparison to the file that you are writing, right? So notifications is here, templates is in the same level, so that's why I just typed templates here. If templates was inside another folder that was in the same level of notifications, I would put the name of this folder here. Anyway, let me close this because this finds the file but does not read. In order to read, I need to call the function read text. So the output of this is going to be the text that is inside of the template. So the output of this is going to be the text that is inside of the file, and it's going to be returned here. I can do the same thing for the others, just change the name. What's the name of the generic? I don't remember. Temp generic. All right. Let's close again. There you go. So choose template now has a real logic that uses another built-in module to get the file and read the content. And now we are using the template based on the status. But let's move to the impressive part, that is really sending an email. And the same way you used a module called HTTP to make an external request using the HTTP protocol, Python provides you a built-in module that allows you to do the same thing with the SMTP protocol. That basically is the protocol that allows you to send emails. So the module that we need to import is SMTP lib. But in order to send emails using this module, you need a real email account, right? Like a Gmail account, for example, because you are gonna need to pass your credentials, both your user and your password, for this module to log in into your email provider and send the email using it as an intermediate. It's not the module that sends the email. The module uses your email account to send the email. So I just created a temporary email to do this, and I'm gonna put here in my code my email and my password. This is a temporary account. I just created this account only for demonstrating how SMTP works. After that, I'm going to get rid of this account. So don't even try to enter this account, alright? Another important thing is never do this. Never put your credentials in your code, alright? I'm just putting here for you to understand how it works. But in real life, you should use an environment variable or a secret manager. There are many solutions to store your credentials safely. I'm only putting here for you to see how it works. You also need some data about the SMTP provider. So SMTP server receives, in my case, my email is from Hostinger, so smtp.hostinger.com. If yours is Gmail, you can put smtp.gmail.com, or you can search for the SMTP URL of your email provider, and also the port that usually is 465 usually. Okay, I have faced some situations where I have put this port and it didn't work, so you need to check in your SMTP provider, your email provider, what is the SMTP server and the port. Alright, with all of this data, I guess we are ready to send the email. So first we create the connection, smtplib.smtpssl, this one right here, and we pass the SMTP server and the port as parameters. This creates the connection. After that, we use our account to log in. So email and password passed as a parameter into the login function that is called based on the SMTP connection. And then we call the function send email. In fact, it's send mail, not send email. Yes. In this function, we need to pass our email as a parameter. Basically, this is the from part of the email. And then we pass the to part of the email, who we are sending this email for. And in this case, I'm going to put some other email of mine, that is felipe@marusacademy.com. And then we also pass as a parameter, of course, the message, alright? In this case, the message is not just the content, but also the subject. So we need to do something here. We're going to create message, and we are going to concatenate the subject with the template. So subject is going to be subject column. You need to put it like this, alright? This module uses this information as the subject of the email. So you need to declare that this is the subject. That's how it works. So subject about your payment, and the message in this case is going to be the template concatenated, the subject concatenated with the template. To finish, we just quit, and we can return just a status like email has been sent. Of course, as you already know, the right thing to do here was mapping the possible exceptions that this module could raise and handling them friendly, okay? But for now, let's just try to send the email. In this case, I hard-coded this email here. It's wrong. I need to fix this here. I'm gonna use the user email that I passed as a parameter here, okay? So those who call the send email function must pass user email and payment status as a parameter. Who is calling now this function? The payment module. In this case, the pay function. And the pay function is also expecting as a parameter the email. So here I can pass the email and the payment status. Alright, now this is gonna work. So we can go to our main.py file, and as this payment was already processed, let's get other payment that was not processed, like this. This one right here was not processed, is with created status. So let's pass the ID here, the value here, amount in this case, and the email. So I'm gonna pass that email of mine at matosacademy.com, and I guess that's it. It needs to work. We are going to pay this order, and if the payment is processed successfully, we are going to update the status in our database, and then we are going to send the notification via email. But this notification is implemented dynamically because it chooses the template based on the payment status, and after choosing this template, it sends the email. Literally sends, not fake sending or simulating sending. It really sends, and you're gonna see it right now. So let's call our main.py function, and let's see what happens. We still didn't get any exception, but the function still didn't finish. Alright. So we have here the status updated. Okay. Before we had this order as created. Now we have this order as processed. Let's see if the email reached my inbox. That's absolutely powerful. Can you see? this is my inbox. This is the inbox of that Felipe at marosacademy.com. You can see that temp at marosacademy.com has sent me this email about your payment. We forgot something. I can show you in a moment, but let's open and see. You can see that we have a bug here because the content of the template is in the subject, but this happens because when we concatenate, let me see here, the subject must end with \n \n. Now this is gonna work. Let's pay this only one left order that was not paid yet. Let's pay it now and see if the email reaches our inbox with the correct format. So we can see that here this works. Let's go to our inbox. Now it's right. About your payment, if I open it, the content is your payment has been processed successfully. Working remotely completely changed my life. Now I have time, energy, and freedom to enjoy the things I love. That's why I created a free training showing the exact steps I use to attract remote opportunities. Check the link below and get free access right now.